All right. Now, sample rates and filtering might seem a little off topic, but they're not. And I hope you see why in a moment. So people always ask me what should I sample at, and there's a lot of questions to ask before I answer that. Um, but first and foremost, like, what are your events of interest? Because that's going to determine what type of instrument you use. Are you looking at real detailed switching events? Maybe then you need 100 megahertz or a scope. Are you looking at power? Now you need to consider accuracy versus frequency. And spoiler alert, power is in the fundamentals, so you don't need that high of a sample rate. Are you looking at faults? Are you looking at that type of thing? That's the higher sample rate too. So you need to balance that. What am I looking at? What signals am I trying to measure? Am I just looking at the signals? Do I just want control type stuff? Do I just want to see my modulation scheme? Or am I looking at calculations, power, reactive power, apparent power? These things, they have different requirements for sample rate. What are your accuracy requirements? And the most important one is, what is the bandwidth you want to see? If you don't know the answer to that, you got to find that answer first. And certainly people like HBK are willing to help you talk through that. But especially if you're a test guy and you get assigned a measurement, like, ask the engineers, what bandwidth do you want to see? And if they don't know, let's have a conversation. So first question. Second question, why are we filtering? Are we just doing anti-aliasing? Cool. We'd help you with that. Am I trying to clean up my measurement from noise? And this is where the relation comes in, because the noise that you're experiencing might not be noise. And if you clean up all of your cabling, you might just be looking at signal. You might just have really nasty switches. And the last one is because we get values we don't expect. And this comes into a different problem, and HBK's got a lot of videos on this. But your RMS, your reactive power, your power factor, those are tied to the frequency content. So if you're getting a value you don't expect in your calculation, you need to ask yourself, what's the bandwidth of calculation I want? So think about these things. And the scary thing is if you filter down to get an RMS value you want, you might eliminate some power. So think about, what's the bandwidth I need for power? What's the bandwidth my engineers want to see for things like RMS? These are questions they might have answers to, because it's things people don't think about, especially when they live in MATLAB and they say, put a filter somewhere, and they never think about it. Got to ask yourself, what are the bandwidths we want for our different calculations? And on the right-hand side, I just have 3 examples of the exact same signal. So we have a 50 kilohertz bandwidth where we have these nice PWMs and this current. And here's my power at 50 kilohertz. It's nonsense, because you need to average power to get a good value. 10 kilohertz. All right, now we get pretty smooth sine waves. We still get a little bit of voltage. And now my power is a little more sane. And then fundamental, where we eliminate all the high frequency content. What do we want to look at? That's not an answer for today. We'll shed a little more light on this. But if you have questions on, like, what do you want to look at? What frequency do you want to know? Please reach out, because these are really interesting topics that are not intuitive, that people don't think about. So why are we filtering? And if the answer is to clean up the measurement from noise, but we did a good job with the cabling, we have to ask ourselves, well, am I doing more harm than good? Because noise is in the frequency range of the inverter. The inverter is creating the noise, but I also want to catch things from the inverter. So which one of these do I want to look at? Do I want to look at the filtered? Do I want to look at the unfiltered? And the issue becomes that filter suppresses amplitudes and alter signals and calculations. So that's when we come back to bandwidth. What's the bandwidth we want to see? And ask yourself, is it noise or is it the inverter? Do I understand my signal? Do I understand my calculations? Because once we start solving those noise issues, we might have different problems we need to solve. And it's understanding how our calculations are done, how our measurements done. We've got a whole bunch of videos on that. We can take that offline. If you have questions, please reach out. But this is really important stuff, because once you solve the cabling, once you solve the EMI, now you get to have the fun problems of, what are the bandwidths? What are the calculations? Just a couple notes on electric power. Inverter signals happen quickly. You need a high sampling rate, 200 kilohertz to a megahertz to get good power information. This isn't going to be switch analysis, but this is going to get you the power, because you want to have that inverter happening. Don't attenuate out your inverter. Power, if you're looking at power, it's contained in the fundamental and its harmonics. So don't filter below your current or your power carrying harmonics. If you look at the fifth harmonic or the seventh harmonic on a really fast machine, so let's say your fundamental frequency is a kilohertz, your fifth harmonic's 5 kilohertz, your seventh is 7 kilohertz. You have a 3 kilohertz filter, you're eliminating power. You might see efficiencies higher than you expect. That's bad. Again, not a noise issue, but if you're filtering because you think you have noise, you're altering your signal unintentionally. And now these calculations. A lot of times people are like, my reactive power is gigantic. It's a calculated value. You have to ask yourself, am I using the right calculation? Because your engineer probably wants to see the fundamental, which is eliminate all of the harmonics, just fundamental. So something to think about. What bandwidth do I need for which signal? Because once you eliminate the noise, now you start getting into the measurement.